myself Akash.
And I'm Vishal.
So we the students of Sardar Patel Institute of Technology pursuing second year BTech degree in Electronics and Telecommunication.
Today we'll be explaining three instruments and giving a demo.
So we will be explaining their principles, their working and their applications.
The three instruments that we'll be looking at are the clamp meter, the LCR meter and the lvdt.
A clamp meter is an electrical testing tool used to measure current without the need to disconnect wires. Unlike traditional multimeters, which require direct contact with the circuit under test, a clamp meter features a hinged clamp jaw that can be used to measure the current flowing through it. A clamp meter operates based on the principle of magnetic induction. When a current flows through a conductor, it generates a magnetic field around the conductor. The clamp meter utilizes this by using a built-in Hall effect sensor to measure the magnetic field produced by the current. A Hall effect sensor is a transducer that produces an output voltage proportional to the magnetic field at its input. This allows the clamp meter to indirectly measure the current without the need for physical contact with the conductor. It has an LCD display. Here we see the power button. It has a built-in data hold function to keep the last reading on display, a wide range of measurement modes which can be changed by using this button, slider and the rotary switch next to it. Then we have our positive and negative input terminals and a hinged clamp jaw that can be opened and placed around a conductor to measure the current flowing through it. One of the main advantages of a clamp meter is its non-invasive nature, which makes it safer and more convenient for measuring current in live circuits without the need for physical contact.
Electrical maintenance used for troubleshooting and routine maintenance of electrical systems, HVAC systems, measuring current in motors, compressors and other HVAC components, industrial settings, checking current in machinery and equipment, residential electrical work, verifying current in household circuits.
An LCR meter is a type of electronic test equipment used to measure the inductance, capacitance and resistance of an electronic component. LCR meters typically measure parameters such as impedance, phase angle, and quality factor, providing valuable insight into the performance and functionality of electronic components. The principle that an LCR meter is based on is the measurement of impedance. Impedance is a physical property that represents the opposition to the flow of electrical current in a circuit. LCR meters work by measuring the current flowing through a device and a test, the voltage across the device, and the phase angle between the measured voltage and current. By analyzing these parameters, LCR meters can accurately determine the inductance L and capacitance C and resistance R of electronic components. Here we have our LCR meter. It has an LCD display. It comes with a USB cable, a shorting bar, and an alligator clip set. Now we'll grab our components and test them out. First, we'll take a resistor. As we can see, the meter works. Next, we'll take an inductor. Now finally, let's test a capacitor.
Manufacturing. LCR meters are extensively used in the production and testing of electronic components to ensure they meet specified requirements. Research and development. They play a crucial role in research and development environments, helping engineers and scientists understand the characteristics of new components. Troubleshooting. LCR meters are valuable tools for troubleshooting electrical circuits, helping identify faulty components or verify the specifications of installed components. So this is the lvdt. It consists of two coils at its end. One is the primary coil and other one is the secondary coil. It also have a moving core attached with a needle at its end that points the values of the displacement. Here we use a digital lvdt to measure the displacement in millimeters to To connect this LVDT to digital LVDT, the four types of connecting wires are used, such that they are directly connected according to their color knobs on the digital LVDT. So basically how it works. If we move the core to the right side, then the magnetic flux around the second primary winding will be more than that of the first primary winding, that is V2 greater than V1, and the output voltage will be always obtained as the negative voltage. For the left side, if we move the core to the left side, the magnetic flux on the first primary winding will be more than that of the second primary winding, that is V1 greater than V2, and thus output will be always obtained as positive. We will get displacement in the digital LVDT as we move the core to the left or right side. We can always see the displacement on it. The readings of the digital LVDT will be always in millimeter. The advantages of LVDT are high accuracy, wide measurement range, reliability, and non-contact sensing. Industrial automation used for position feedback in machinery and automation systems. Aerospace employed in aircraft systems for monitoring critical movements and positions. Civil engineering applied in structural health monitoring to measure deformations in buildings and bridges.